So you need to go back to your handouts. You should have had 7.1a and b, 7.2 and 7.3. Any of these terms would be somewhere in there. Some of them are going to be like definitions, like rotational motion, and it has this, definition for it. Others you need to understand where it's going to be used, recognize it in your word problems, etc., even if it doesn't have like a word for word type definition. You do need to understand Kepler's law of motion and Newton's law of universal gravitation. Those were in, I think, like the last section there that we did. And then we started doing some of these problems. So we're going to go through these together really quickly. And then I gave you some sample ones to work out. So a toy sailboat is attached to a strings moving in a circle with a radius of 0.85 meters. If it completes 12.6 revolutions, what's the total distance? What you need to remember is revolution versus radian. So if I have a revolution, in this case I have 12.6 of them. Each revolution is one circle. Remember, one circle in radians is 2 pi. So that's how far I have gone in radians. They wanted distance in meters. If I just wanted radians, I would be done, how far I went. But because they want it in meters, I'm going to then multiply by that radius. And you're going to get some long number. How many significant digits do I need here? 2, so I should say 67 meters here. So from that, we move to velocity. We've done velocity. Velocity is just how far I traveled divided by the time. But now we're just doing it with angles. So the first way that we looked at velocity was just radians per second. All right, and so radians per second, I'm going to take those revolutions. I'm going to multiply by that 2 pi. And then I'm going to divide by how long it took me. Or you could multiply by 1 over 0.15 seconds. They want radians per second. So this first piece is just converting the revolutions to radians. The second piece is dividing by the number of seconds. In 3 significant digits, I'm at 14.7 radians per second. They're also asking me to do this in revolutions or rotations per minute. I already have the rotations, so I don't need to convert to radians if I'm just leaving it as revolutions or rotations. I still need to divide by that time, that 15 seconds. But now they want revolutions per minute. So the only thing I have to do here is convert it to minutes. There are 60 seconds in every 1 minute. So they're just making sure that you understand, the difference. I am going to put a decimal there, or I'm going to underline that 0 to make sure that you know that it's 3 significant digits there. All right, so for the next one, centrifuge starts from rest and accelerates to an angular speed of 8.2 times 10 to the third RPMs in 2.5 seconds. The radius of the centrifuge rotor is 0.120 meters. What's the average angular acceleration of the centrifuge? So this one they have given me that it starts from rest and goes to this particular speed. So if I'm doing acceleration, remember acceleration is just my velocity over time. Think of it that way, right? We need it in radians per second squared. So my starting velocity obviously is 0. It got to 8.20 times 10 to the third RPMs. But I needed to convert RPMs to radians. So for A, the first thing I'm going to do is I'm going to convert these RPMs. And I'm going to say rotations. I'm going to write it like this per minute. And I'm going to convert this to radians. All right. I do want acceleration in radians per second squared. I am currently in minutes, so I'm just making a conversion here. 1 minute is 60 seconds. That's going to be my angular velocity. They want angular acceleration, means I take that velocity in radians and I divide it by the time. Well, it took me 2.50 seconds. So divide by that or multiply by 1 over 2.50 seconds. Same thing. And I will get my radians per second squared. So really, I'm just taking my angular acceleration divided by my time, right? My angular velocity divided by time is my acceleration. The only difference here is they gave it to me in rotations. I need it in radians. Convert it and then divide by your time, right? Rotations per minute, convert it to radians per second, and then divide that angular velocity by your time. So that's the answer to the first question. The second question is, what is the magnitude of the tangential acceleration? Lots of words going on there. Again, those are words you should know. This is where we involve the radius, all right? And so if I want radians per second squared and I want to convert it to a meters per second squared, I'm just going to take my answer and multiply by my radius. And that will now change it to meters per second squared. So once you have your angular acceleration, you just convert to your meters per second squared by multiplying by that radius. So this is when we get into our initial squared, our final squared minus our initial squared over 2 times our acceleration, things like that. So these are just like our beginning of the year ones, but we're just using angles instead of our linear. Turntable starts from rest and undergoes a uniform angular acceleration of 1.5 radians per second squared. So this is my acceleration. All right, we're going to use that in a minute. How many revolutions will it make before reaching an angular speed of 36 RPMs? So again, we're not going to use RPMs here because everything in my formula is going to be in radians. I'm going to convert it back to RPMs at the end because that's what it's asking for. But to use my formulas, I really need to be in radians. So once again, I'm going to convert this angular speed of RPMs to radians. So once again, I'm going to take that RPM. Remember, I am rotations per minute. I'm going to write that out. Convert the rotations by the 2 pi. That's going to give me my radians. Convert the minutes, like we always do, to seconds. 1 minute is 60 seconds. And I should get about 3.77 radians per second as my final speed here. So if you'll remember, your change in theta or your change in distance is what we used to use. Change in x is what we used to use. Change in theta is what we use now. All right, so change in theta is going to be my final speed or velocity squared minus my initial velocity squared over 2 times my acceleration. All right, that's from the very beginning of the year, but now we're using angular instead of change in x, like that. So my final is this guy. That's what I just calculated. My initial was 0, so that's pretty easy. We're going to take 3.77 squared minus 0 over my acceleration. That's what they gave me at the beginning, 1.5. So when you do that, remember you are in radians. So we're going to go backwards with this. When you do that, you get like 4.738, I don't know, radians that it has moved. That's your movement, angular movement. They want it in rotations. How many rotations? Well, if I take rotations and multiply to get radians, how do I go from radians back to rotations? If I take rotations and multiply by 2 pi to get radians, how do I go back the other way? What am I going to do? Divide by 2 pi. So take him, divide by 2 pi to get him back to where you want him. And you're going to get 0.75 revolutions. The reason I didn't leave it in revolutions is because this formula with squaring it is assuming it is in radians. This formula is assuming it's in radians. And so you have this 2 pi that would have squared that would not have done that if you didn't already have it in radians. So you want to convert it back at the end because they did ask for revolutions. If they had said what was the angular movement, you could have left it in radians. That's valid. But because they said how many revolutions, you want to divide it back out. 2 children are on a seesaw with a pivot at the center. Child A weighs 315.5 and sits 1.1 meters from the pivot. Child B weighs 280. How far must child B sit? So you're basically going to end up with the one that it gave you, 315, times how far away he is, 1.10. Right? If your forces equal each other, then that will equal the force of the other child times how far away he is. And that's what we're solving for, right? So assuming they're balanced, right? The force of this guy times its radius should equal the force of that guy times his radius, right? So to solve for radius, what am I going to do? Just divide. So if in your calculators, you can just divide that 280 over to solve for that radius, which means it's going to be 315.5 times 1.10 divided by 280. This is 3 significant digits. You should get something like that. Next one's very similar, except you're going to use the whole length of the guy instead of like assuming it's in the center. So the one above it said assume that pivot is in the center. The second one's saying, hey, but the pivot doesn't have to be in the center, but I want to make sure that it balances, right? And so this is where you take your whole length, that 4.5, the radius of the one you want. Well, the one I want is the 85.2. He's going to be my numerator right here. The other one's going to be my denominator. And remember we did a factoring. We factored it out. That would be the r multiplied all the way across, because you end up with, like, if I do 4.5 minus the r, it's this whole, what we manipulated the problem there with that. And then you're just doing basic division, right? Divide that whole group over. You can do it in your calculator. Just make sure you use parentheses. In your calculator, you can say 4.5 divided by, do open parentheses. It will do this part correctly. You don't need another set of parentheses. It will do all of that for you. We're just solving for that radius. So it's going to be the radius of the one they told you. They said from this guy. He will be your numerator. The other one will be your denominator. It's always going to be a +1 because of how we factored this guy out. And you should get approximately, to 3 significant digits, 2.68 meters. That's how far away it needs to be from the 85. Your own tangential speed, this guy right here. So if I wanted to find my magnitude of my centripetal acceleration, my acceleration is actually going to end up being, the kilograms don't matter at all. So the mass doesn't matter at all here. What matters is my tangential speed. So that tangential speed is going to be my numerator here. That's like my velocity, right? But in circular motion. And I'm going to divide that by my radius. So you're going to take that tangential speed, that will be squared over your radius. That's what you're looking for these, your tangential speed squared over your radius. And again, this is stemming from our equations we had at the very beginning of the year. This is going to be 3 significant digits. Again, you can do all of that in your calculator. Acceleration is meters per second squared. So here is where your mass now makes a difference, because we are now went from tangential speed to centripetal force. Force is mass times acceleration. Our acceleration we just found was that tangential speed squared over our radius, right? However, now we have to include mass because we're talking about force. So the force they gave me, your force is going to equal the sum of the masses, technically, times your acceleration, which is that tangential speed, which is what they're about to give us, over our radius. So that's what our force is going to be, mass times acceleration. And remember, acceleration in this case is going to be that speed squared over our radius. So we're going to fill in what we know. We actually know the force. They gave us this force right here. Force, and this is in scientific notation, obviously. Force equals mass. Well, now we need a mass. Mass is always going to be that kilograms. Mass. What is the speed? Oh, all of a sudden we're solving for that, right? We're solving for that speed. So we're just gonna, you can label it however you want. I don't care. All right. Whatever you need, it is a variable. That's what you're solving for. Over our radius, the radius of the orbit, they also gave us that too. So how do I solve for that? Well, you need to multiply by the denominator, divide by the 6.8, right? Once you get that, you need the square root, right? You can do it all in your calculator, or you can do it a piece at a time, or you can use your answer key. But in your calculators, you can do square root. If you do it with a square root, make sure we use some parentheses going on. But then remember, you should have like a scientific notation button. If you have a smaller calculator, you may have to do it a piece at a time. Multiply by the 7.1 scientific notation. Divide by the 6.8 scientific notation. Close parentheses. You should be able to do all of that with that square root. Or you're welcome to do it a piece at a time if you're nervous about that. And then you can check your answers that way if you want to. I am going to give it back to you in scientific notation. I think you get like 7647 or something like that. I only want 2 significant digits. This is 2 significant. That one is 2 significant digits, and that one is 2 significant digits. So when I give this answer, I'm going to take that 7,647, and I'm going to say 7.6 times 10 to the third. And that is speed, so it's meters per second. Speed, meters per second. All right. I just converted this 7647 to scientific notation. If you didn't do scientific notation, you would need to round that to 7,600, 2 significant digits.
So we don't have something.
Not necessarily. Not necessarily unless I ask for it. I would say as a general rule, though, you likely want to give it back to give your answer back the way most of your numbers were given to you. So that's a general rule for things. But either way, as long as you include the correct number of significant digits, you're good. A car with a mass of 1.55 times 10 to the third kilograms is traveling around a circular track with a radius of 75 meters. The maximum friction, remember friction is a force, right? The maximum friction the road can sustain is 9.2 times 10 to the third. What's the speed at which it can safely travel? Question 8 and question 9 are the same exact question. Same question. They just worded it differently, right? They gave you friction, which is a force. They gave you mass. They gave you radius. They're asking for a safe speed, which is what we just solved for. You would do it exactly the same way. All right? So go ahead and try it. Go ahead and try number 9 on your own.